This is a CURTA calculator, a 20th century mechanical calculator. It performs addition and subtraction, and can perform multiplication and division through repeated addition and subtraction. An addition operation is performed in the following way. First, the setting sliders are set to select the first input. When a setting slider is moved to a certain position along its setting shaft, a helical groove in the shaft, mated with a screw in the back of the slider, turns the attached number dial at the top of the shaft to the corresponding digit. The slider snaps into place along the shaft due to a small spring and ball inside the slider, which fits into a number of spherical detents. Each setting slider has two protrusions, which slide a count gear up and down its transmission shaft. When the crank handle is turned, the step drum is rotated. When a count gear is moved into a certain position in addition mode, it meshes with a number of step drum teeth corresponding to the digit entered on the setting slider, which turn it the number of fifth turn increments specified. This drives the transmission shaft. At the top of the shaft is a transmission gear, which meshes with the teeth on a numeral dial. This turns the numeral dial as many increments as the count gear, thus incrementing the dial as many times as specified by the setting slider. The setting sliders are then set to select the second input, which is added to the current figure. You may have noticed that this alone won't perform the carry operation required when a digit rolls over from 9 to 0. This is taken care of by the carry system. The carry system functions as follows. The carry pin, mounted in the numeral dial, makes contact with a carry lever when the dial turns from 9 to 0. When not performing a carry, the carry lever is held in its upper position by the carry lever spring, which supports the carry lever by two triangular protrusions. As the carry is initiated, the pin pushes the carry lever into the down position, where it is locked by the carry lever spring as before. The carry lever's arm is sandwiched between the tens gear and locking assembly on the next higher transmission shaft. This assembly consists of 3 spacers, a lock gear, and a count gear. We'll focus on the count gear for now, since it performs the carry operation. When the carry lever arm pushes the assembly into the downward position, the count gear is moved into the path of the result counter carry increment disc, which is mounted to the tens bell and is driven, like the step drum, by the main shaft. There is a single tooth on this carry increment disc, which is positioned so that it follows the teeth on the step drum as the crank is turned. This tooth mates with the count gear and increments the transmission shaft to the left of the one which performed the carry once, incrementing its numeral dial and thereby effectively adding 1 to the next highest digit. On the next turn of the crank, the carry lever is restored to its upper position by the upward sloping protrusion on the carry increment disc, moving any previously lowered count gears out of the path of the disc's tooth for the following turn, until they are activated by the carry pins again. In order for all of this to happen smoothly, there are a few measures which prevent errors and improve user experience. One such measure is the locking system, which locks the transmission shafts in place when they aren't being turned by the teeth on the step drum. Returning to the tens gear and locking assembly from the carry system, the upper lock gear mates with either the result counter carry reset ring or the result counter lock ring, depending on the position of the carry lever. In either case, the portion of the turn where the transmission shaft needs to be fixed, the lock gear's concave face locks against the cylindrical face of either ring, preventing the shaft from rotating. Indented slots in each ring allow the shafts to turn when being driven by the step drum or the result counter carry increment disc, with the only difference between the upper and lower rings being the lower ring's longer slot, which allows for the turning of the transmission shaft by the carry increment disc when the carry lever is in the lower position. Another set of features which allow for smooth operation can be found on the bottom of the CURTA. The zero positioning system guides the main shaft back into its starting position after a full rotation by means of the zero positioning disc and the spring-loaded zero positioning roller, which is pressed into the circular divot on the disc and resists its rotation in the starting position. The zero positioning disc also has a series of teeth which mate with the spring-loaded non-return ball, which prevents the shaft from rotating in a counterclockwise direction opposite the intended direction via a ratcheting mechanism. Additionally, to ensure that the numeral dials snap into the correct positions to display digits clearly, a spider spring pushes steel balls into the teeth of each dial. This indexes each dial to one of 10 positions corresponding to the digits 0 through 9. Returning to the primary functions of the calculator, the turns counter is driven similarly to the result counter. The reversing lever, as mentioned previously, switches the turns counter between incrementing and decrementing for each operation. We'll focus now on incrementing, which is the top position. The reversing lever moves vertically along the reversing lever axle, which is held in its two positions by a similar mechanism to the setting sliders. A small spring and ball snap into one of two detents along the axle. The lever contains the reversing lever plate, which slides 6 count gear assemblies along their transmission shafts, which, through transmission gears, drive numeral dials as described earlier. Note that the rightmost count gear assembly contains 3 count gears as opposed to the one on every other. In incrementing mode, the bottom count gear in this assembly is turned by a single tooth step drum plate in a set of plates opposite the result set. We'll call this the turn set. None of the other count gears mesh with these plates in incrementing mode, and so 1 is added to the turns counter with each revolution of the crank. The carry system for the turns counter is very similar to the results counter carry system. However, there are a few key differences. This is because the lock system, which also functions similarly to the results counterpart, requires its own set of locking rings, the turns counter lock ring on the top and the turns counter carry reset ring on the bottom. This is needed because the turn set of step drum plates is opposite the result set, so the turns counter locking rings need slots aligned with these plates to allow the transmission shafts to turn. Due to the elevation of the second set of locking rings above the results counter set, a separate turns counter carry increment disc is also required, as the count gears which handle carry operations, as before, are in the same assemblies as the lock gears. To accommodate this higher position, the turns counter carry levers are also modified, and their arms extend to the lock and count gear assemblies through a slot in the upper main casting. We've now covered all mechanisms involved in addition. In order to understand how the CURTA performs subtraction, you first need to understand 9's complement subtraction, a useful decimal system trick that allows subtraction by adding. To calculate a difference, the subtrahend's 9's complement is taken by subtracting each digit from 9. This is then added to the minuend, and the leftmost digit, which is always a carried 1 when the difference is positive, is removed and added to the ones place. This trick, which allows the device to reuse much of the addition hardware, is implemented on the CURTA in the following way. First, the first input must be selected and added to the result counter as before. For this example, we'll use the sum from the addition example. Then, the crank handle is lifted, which must be done at the starting position due to the interlocking mechanism of the step drum positioning tongue and step drum positioning cam. When the crank is lifted, the step drum moves upwards, while the tens bell is fixed in place and slides along the main shaft instead. While in this position, the step drum positioning spring can snap between the sides of a set of sloped holes on the step drum, holding the step drum in either the up or down position while allowing it to be moved with enough force placed on the crank handle. When in the up position, the subtraction step drum teeth mesh with the count gear assemblies. However, instead of having the corresponding number of teeth for the vertical position of each digit, the subtraction plates have the teeth corresponding to the 9's complement of each digit. The 0th position has 9, the first has 8, and so on. In this way, the 9's complement is added to the figure currently displayed by the result counter. Because 9 is added to every leading 0 digit on the dial, the carried 1 causes each 9 to roll over to a 0, carrying the 1 forward until it reaches the end of the carry system and is removed from the result because it can be carried no further. This effectively removes the carried 1. To add it back to the first digit, the first digit count gear assembly differs from the other result count gear assemblies in that it has a second count gear positioned above the first. This meshes with the next highest subtraction step drum plate, adding an extra 1 to the numeral dial and completing the 9's complement subtraction algorithm. For the 0 position, a special 10-tooth step drum plate adds 10 to the first digit. In subtraction mode, note that the turns counter step drum plates are also moved upwards. In the incrementing position, this causes the teeth of each turn counter count gear to mesh with the 9-tooth step drum plate. This effectively subtracts 1 for each turn by 9's complement subtraction, as the first dial is incremented 9 times. The 9's complement of 1 is 8. Since this is the first digit, 1 more is added to get 9, and the remaining dials are incremented 10 times due to the carried 1 and returned to their original positions. Note that this is also what happens if the reversing lever is set to decrement in addition mode. Finally, if the lever is set to decrement in subtraction mode, the turn's counter increments, as only the top gear in the 3-gear count gear assembly on the first digit meshes with a 1/2 step drum plate. The turn's counter is most useful in multiplication and division operations, which are not covered as they are accomplished through the same mechanisms.